Mba. Mba, so let us continue and finish up. The traditional method. So we did the traditional methods a few minutes ago. Now let us look at the z-test for the mean using the p-value method. P-value simply means the probability value. So working with the rule for that is simple. It's still the hypothesis. It's even similar to the traditional method. You state the hypothesis and identify the claim. You compute the test value, find the p-value, make a decision, summarize results. Now, the criteria for rejection is if the p-value is less than or equal to alpha. Reject the null hypothesis. But if the p-value is greater than alpha, do not reject my hypothesis. So it is the opposite of the traditional method when it comes to making decision. Let's try an example. Okay, it says a researcher wishes to test the claim that the average age of lifeguards in Ocean City is greater than 24 years. She selects a sample of 36 lifeguards and found that the mean of the sample to be 24.7 years with a standard deviation of 2 years. Is there evidence to support this claim at alpha 0.05? Use the p-value method. So for this, what we do is to first thing again, like to state null hypothesis and the alternative hypothesis. So I'm gonna make this 16. So HO and H1. Okay, I'm gonna make them to be, on board. It says a researcher wishes to test the claim that the average age of lifeguard in Ocean City is greater. So greater than can only be used in the alternative. So you can put it there. Average age symbol mean is greater than 24 years. And that is his claim. Now, there are no hypotheses say the opposite of this one. Claim is mean is less than 24 years, but you cannot use the symbol less than in the no hypothesis. You can only use less than or equal to. So you have mean is less than or equal to 24 years. Okay. Now, our alpha is 0.05. You can put it there. Okay. Now let us now list our values so I can run the test. Because it says here, compute the test value. To compute the test value, we need the average age of lifeguard in Ocean City is 24 years. And he selects, so that means mean is 24 years. 24 years. So he selected 36 lifeguards. So N equal 36. And find that the mean of this sample is 24.7 years. Now, that is sample mean. We cannot have it, we don't have the character for sample mean here, so we can go and get it from the other workbook. So I'll take you there. Okay. So have the S bar. Okay, X bar. X bar equals 24.7 years, I believe. 24.7 years. Let's make sure. Yeah, 24.7 years. Okay, 24.7 years. Okay, 0.7. So we can copy it from here and paste it there. 24.7. And standard deviation is I said the standard deviation is 2 years. So standard deviation is 2 years. Standard deviation is 2 years. So I'm going to make it bigger. So now we are ready to run the test by computing the test value. Okay. We have all the information we need. So let me write them down. We got population mean is 4 years. Sample size is 36. Sample mean S bar is 24.7. Standard deviation is 2. So our formula is Z equals X bar minus mean standard deviation over root N. So let's go and put them in the other workbook so we can get our equation. Put them in the formula and then copy them here. So Z equals, okay, as usual, have S bar, okay, minus mean, okay. Our mean is right here, divided by standard deviation of this by the square root of n, which is which is I think I put you in the wrong, which is right here, which is I have this. Our sample mean is 24.7 minus population mean is 24 divided by standard deviation of 2 over the square root of n. N is 36. N is 36. So we can get our answer from this. Let me write this down. 24.7 minus 24 divided by standard deviation of 2 over square root of 36. So we can go and get this from the calculator. And then complete the test. So have S bar is 24.7 minus 24 divided by standard deviation of 2 over the square root of 36. Okay. 2.1. 2.10. Okay. 2.10. So I'm going to take it to the main work, to the our workbook, put our answer, then copy it to the main workbook. 2.10. And copy that, put it right there. Okay. Put on the main workbook that we're using. So I run our tests. This is the result, 2.1. Now, this is the p-value method. So it says calculate the test value. Then next thing is to find the p-value. Find the p-value. So let us find the p-value. P-value, remember, if you it says here, if you look at the claim, it says greater than 24 years. When you draw the chart, it will look like this. Okay. I have 0 here. Then I have our answer, which is 2.10. So I'm gonna make this 16 so it will be big enough. So let's draw our chart. You can see how our chart looks like. Okay. It goes okay right here. Then we have, I think I'm gonna move it a little bit down. Okay. Then we'll have our line, the axis here. Then I put this line here. And this is 2.1. So the line is gonna be here. 2.1. And then you can share it. Okay. You can see it from here to the shading. Okay. All right. All right. This one takes time. Shading is the part that takes most of the time. If you're doing it with hand, it takes faster. But except if you're a good drawer with the Microsoft Word. So you can see that's how it looks like. And whenever it's at the tail, you subtract from 0.5. So p-value, our p-value now become p-value. Value. I'm gonna make this bold and 16. Okay. P-value equals 0.5 minus. Now look for this number in the table of normal distribution. Because remember, this is half of this is 0.5, this half is 0.5. So if you're looking for only this part, subtract 0.5 from the area. And this area you find from the table of normal distribution. So that we have that table right here, 2.10. Okay. 2.1 is right here. 2.1. See, this is the Z. So 2.1 under 0. Yeah. So 2.1 under 0. This is the 0 right here. Right here. This is 2.1 under 0. It's 0.4821. 0.4821. Okay. 0.4821. When you subtract this, let me write it down. 0.5 minus 0.4821 give us the p-value. Okay. I have 0.5. 0.5 0.000 minus 0.4821. 0.0179. 0.0179. Write it down. 0.0179. Okay. Write it down. Yeah, 0.0179. Where is it? Where is our class? Okay. 0.0179. So now you have find the p-value. See, we have we still our hypothesis. We computed the test value. We find the p-value. Now let's make a decision. Remember how to make the decision. If the p-value is less than or equal to alpha, you reject. But if the p-value is greater than alpha, do not reject. So let's make our decision. Okay. Decision. Okay. Our alpha is right here. Is 0.05. Okay. Our p-value. P-value. Value equals 0. You can see right here. 0.0179. So you can see that this p-value is less than alpha. This alpha is 0.05. This is 0.01. So it's less than alpha. So we reject HO. HO because 0.0179 is less than alpha. It's less than 0.05. 0.05. So we're rejecting more hypothesis. So we're rejecting this. We're rejecting this one. That means we are accepting this claim. And the claim is that the average age of a lifeguard is greater than 24 years. So since we're rejecting HO, we're accepting H1. That's the claim is correct. So just HO. Conclusion. Okay. Okay, is that there is sufficient evidence to support the claim that the average age is greater than 24 years. So that's the end of it, of this question. Now, I want to show you something. If this is a two-tail test, that means if you're using equal to and not equal to, in that case, you have two sides. There'll be shared in this side and in that side. In that case, the p-value will be whatever answer you get here, you multiply it by 2, because it has to be two sides. So we multiply by 2 before you make your conclusion, if it is a two-tail test. Any question on this? Any question? Hello?
No questions.
Good. So now let us round up by doing the test for when the sample size is small. T-test for the mean. What is T-test? What we have been doing so far is Z-test. Now, T-test, we use T-test when the sample size is small. That means when it's less than 30. So basically, the T-test is a statistical test for the mean of a population. And it is used when the population is normally or approximately normally distributed. The population standard deviation is not known. So that means we have to use the sample standard deviation. And the sample size is small, means less than 30. In that case, we don't start writing T, right? Z, we have write T. And then we use the sample standard deviation S. Now, T distribution is, we did it when we are doing confidence interval, is based on degree of freedom, DF, which is n-1, which is based on sample size. So in that case, we're not going to use the table of normal distribution. We will use the table of T distribution. Like I said, I've already shown you how to use T table. So let's do this example. Look at this one here. This is our last example. It says that a job placement director claimed that the average starting salary for nurses in 2000 is 24,000. A sample of 10 nurses salary has a mean of 23,450 and the standard deviation of 400. Is there enough evidence to reject the director's claim at alpha 0.05? You say the average starting salary is, so it is is means equal. So you have HO, and you can only use equal in HO. The mean equals $24,000. That is the claim. Okay. H1. Now, say the opposite. The mean, okay, is not equal to 24,000. Okay, and alpha. We're going to solve this using the traditional method. So our alpha equals 0.05. Okay. Now we have let us list our values. So alpha is 0.05. Now, how do we know that we're going to use T-test here? First of all, sample size is small, 10 nurses. And we don't know the population standard deviation. So we're using sample standard deviation of 400. So that's how we know. So our N is 10. Okay. And degree of freedom, DF, equals n minus 1, which means 10 minus 1, that gives us 9. So that's critical value. Our critical value, okay, which is P alpha over 2. So excuse me, T alpha over 2, because it's two sides. T alpha over 2, since it's less than, or it can be greater than, it can be less than. It's a two-tailed test. T alpha, what's my alpha? Okay, let's see. Alpha over 2 equal. So we go to our table under degree of freedom 9 and alpha 0.05. Okay, so I'm gonna take you there. So this is Z table. We're not gonna use this, we're gonna use T table. This is the T, student T distribution. And where we have a double prime is for 2 tail, which is what we have. 0.05 is right here. With 9 degree of freedom, this is 9 right here. So it go under 0.05, which is right here. So see, it's under 0.05 with 9 degrees of freedom, 2.262. 2.262. So 2.262. So we go and put it. That's our critical value. This one is more straightforward. 2.262. Okay. Now we're ready to run the test. Our population mean is 24,000. 24,000. And okay, sample of 10 nurses. N is 10. We have it here already. N is 10 nurses. Okay. Then sample mean, the character, we can't get it from here. We can get it from the other workbook, 23450. The sample mean. So I'm gonna take it so you can get the sample mean. X bar. Okay. So our X bar equals 23450. Okay. You can copy it and paste it there. 23450. So you have it right here. 23450. Standard deviation. So we're gonna use a sample standard deviation of S. The S represents sample standard deviation is of, let's say it is 400. 400. So let me write this down so you can see what we have. Super. We got this X bar is 23,450. Population mean is 24,000. And the sample standard deviation is 400. And sample size is 10. Now we're going to compute the test value. Okay. Remember that for the traditional method, if your answer is greater than critical value, we reject. If it's less than critical value, we don't reject. So let us go and run the test. Okay. So instead of, because this is a T test, we're going to use this formula T. S bar minus mean divided by sample standard deviation over root n. Instead of writing Z here, I'm using the delta, I'm using T. So we go and put it on the on our other formula paper, so we can get the formula. So you have T, excuse me, T equals to get sample mean here, which is X bar minus population mean is mean divided by standard deviation of S over square root of n, okay, of sample size. which is, okay, it has sample mean of 23,450 and 24,000. Whatever standard deviation of 400 over square root of 10. So we can go and put this in the calculator and get our answer from there. Okay. That is to have 53,450 minus 24,000 divided by standard deviation of 400 over the square root of 10 negative 4.35. See, approximately negative 4.35. So you have negative 4.35. Negative 4.35. Okay, so you can copy it. So have, what is it? Negative 4.35. Now, you can make our decision. Okay. The calculator critical value is this. Critical value right here. Right? So you copy it and put it right there. So you can compare it with our answer, which is the calculated value. Calculated value which is just T, equals I have negative 4.35. But because this is the you know, you're using the absolute values. If you remember the absolute value in the algebra, absolute value is always positive. So this is the absolute. So you're gonna use the absolute value actually. So we're gonna use the absolute value. So the absolute value of this number, see, okay. So which give us equals 4.35. So you can see that based on that, the calculated value is bigger than this. So our decision will now become reject HO because 4.35 is greater than the critical value of 2.262. Okay, that's our decision. So that now conclusion will now become, now since we rejected the HO, so since we got HO here, that their salary is the average salary of nurses in 2000 is 24,000. So we are rejecting the claim because we are rejecting non-hypothesis. So that means there's not enough evidence to support the claim. So the conclusion, there is insufficient evidence. There is insufficient evidence to support the claim that the average salary of nurses in 2000 is 24,000. So there's not enough evidence to support it. That is it. That's our last example. Any question on this? Any question, guys? Okay, no question. So now, if you have this type of question that lists the numbers, all you have to do is to find their mean using the method I showed you how to get the mean. Or you can get the mean and standard deviation using an Excel, and then you follow the same process and get the answer. So that will end our class for tonight. So we have finished the test of hypothesis. Next week, we round up the class by doing a regression and correlation. And I will see you guys next week. Before we leave, does any of you have a question for me? Hello? Hello?
No question.
No question. Okay. All right. I'll see you guys next week then. I'll put the classwork for you, and then you can do them tonight or you can do them tomorrow. Okay. Have a good night.
You too.
Thank you.
You're welcome. Bye-bye. Mine with 3 sessions. Second one, Anna Delfrana drop.